This lesson today is going to focus on using domain and range from continuous and discrete data. Our essential question today is or statement is to describe how to identify the domain and range and determine whether or not the data is discrete or continuous. These notes are going to mainly focus on continuous versus discrete. So looking at our continuous data and discrete data, let's talk about the differences. Continuous data is going to have a graph that is unbroken. Graph is unbroken. So it's going to be a line. Okay, so a graph is unbroken. And you can measure the data at any value. Okay, for example, I could measure your weight at any given age. I could measure it when you're 3.5 years old. I could find out your weight when you were 3 years and 4 months. We could measure it at any given point. One thing really important to remember about this is when we do write the domain and range for this data, the domain and range will be written as inequalities when we're talking about continuous data, written as an inequality. If you look at the graph below, this is an example of a continuous graph. There isn't any specific real-life data associated with it right now, but this is an example of a continuous graph. If we were to identify the domain of this data, we're going to look at the x values. Notice our x values go from right here all the way to, it looks like it's continuing on because it has this arrow on the end. I want you to notice that this point right here is a closed circle. Closed circles means that it can be equal to. But if it has an open circle at that point, then we have to think that it cannot be equal to that. So for this particular domain, we would say that x is greater than or equal to 0 because it can be 0 and then anything greater. And we know it goes on and on because of that arrow. Now let's talk about discrete data. Discrete data, its graph consists of isolated points. Whoops. The graph consists of isolated points. And so what that graph is saying when it has isolated points is you cannot measure at any point on the graph. Okay, so an example of this might be that you go to Brahms and you buy an ice cream cone. Well, you're paying for an ice cream cone probably by the scoop. You can't get 1.5 scoops of ice cream. So you're not going to be able to measure, say, the cost of an ice cream cone to the number of scoops continuously. It's going to be based on 1 scoop, 2 scoops, 3 scoops, 4 scoops. Okay? When we write the domain and range for discrete data, the domain and range are going to be specific values. So we're going to list the actual numbers that represent the domain and range. Looking at the graph on your paper, you see how these are isolated points. It's not a line. When we list the domain, we're going to look at the specific values. We're going to put this in brackets. We know that x can be 1. We know x can be 2. It can be 3. It can be 4. And it can be 5. And so that's how we would list the domain. And then for our range, we would do the exact same thing, but now we're looking at the y values. And it just so happens that y can be 1, y can be 2, 3, 4, and 5. So it is the same as the domain. Okay, let's look at these verbal examples because that's when it gets a little bit trickier to determine whether it's continuous or discrete. The first example says the number of texts you send in a week. Well, the thing to ask yourself is, can you send half a text? If you can send half a text, then that would be considered continuous data. Now, I know you're probably thinking, well, I could send a text halfway finished, but you can't cut that, you can't chop that text cell in half. So technically, when you send a text, you're sending one text. So this would be an example of discrete data. Okay. The next example is the weight of a cake. So think about it. You have a cake and you weigh it. Could I cut away some of the cake and now have maybe 3/4 of the cake or half of the cake, and could I weigh it? And the answer would be yes. So as we cut away pieces of the cake, we could measure it at however much we had left, and we would have parts of the cake left. And so that would be an example of continuous data. Okay, what about how tall you are? Can you measure at any point how tall you are? Or does it have to be at intervals of time? And the answer is yes, you can measure at any point how tall you are, and so that would also be an example of continuous data. Okay, and then the last one says the amount of money you spend on music downloads. So the question is, can you buy 1.5 downloads? The answer is no. You can buy 1 song, 2 songs, 3 songs. You can't buy half a song. So you can't measure in between 1 whole song and 2 whole songs. And so that would be an example of discrete data. It's trickier when we're looking at it from verbal. Okay, so let's look at the last 2 graphs and talk about whether they're discrete or continuous. I want you to determine that for a minute on your own. Which one is discrete? Which one is continuous? Okay, hopefully you said that this graph is a discrete graph, and this one is the continuous graph. And so now what I want to do is I want to look at identifying what the domain and range is. Remember, domain is the set of all the x values, and so we're going to list all the x values for this graph. So on here we have 1, we have 2, we have 3, 4, 5, and 6. Remember, discrete is a set of numbers. Okay? Now for our range, a little bit trickier because I do want to list it in numerical order. Notice our numbers are going from -1 all the way up to 6, but we're not including all of those numbers. So my lowest point, y is -1, and then moving up, my next lowest point, y is at 0, and then 1, and then 2, and then 3, and then 6. And so that is how we would identify our domain and range. Looking at our continuous graph, remember our domain and range for continuous is going to be listed as an inequality. Now this graph is different than our above example because it has 2 stopping points. It goes from -4 to 3. And so we're going to write what's called a compound inequality. We know that the lowest x can be is -4. We know the highest it can be is 3. Now notice we have open circles. We said open circles mean it cannot be equal to it. So we know x is going to be greater than -4, but not equal to it, and it's going to be less than 3. So that was what a compound inequality would look like. Now for the range, we're looking at the y values. So notice our y values are going from 1 up to 5. So we're going to write our lowest number on the left, 1, Our highest number on the right, 5, with our y in the middle. Looking at the 1, it's got a closed point, so it can be equal to, and then we know all the other y values are greater than 1. Okay, and then for 5, 5 is the maximum, so y is going to be less than 5, but it can't be equal to it because we have a closed circle.